Okay, good morning, students, or good day. We are looking at, I promised this video for quite some time ago, and sorry for the delay in putting it up, but this is the final video regarding flowcharts. Alright, flowcharts are very, very easy. Alright, extremely easy. I mean, easier than 1, 2, 3. Right, but like everything else, it requires some patience. And oftentimes, as I tell students, if it's easy to learn, it's also easy to forget. So be patient with it. Make sure you work it in, because once you get it, that is it. All right, that's something I can put behind you, and you know that's a little bit less studying and preparation for the exam. So today we're looking at the flow charts, primarily those geared toward the process of loops. All right. Now we're going to discuss a little bit of a nuanced approach to that. And there's a particular trick with for loop situation where you don't really have loops for that. You tend to convert them to a while loop or repeat until loop. But we'll discuss a little bit toward the end of the video. All right. Now here is a Pascal program, right, with a loop. All right. So we went through some of these before in Pascal, linking back to the same videos on the channel, where you have circumference. You calculate the circumference for a circle. So we know how that goes, right? You have the radius, and you have pi, and you multiply all of that by 2. All right, because double the radius, so you get a diameter, and the diameter will go around the circumference of a circle 3.14 times, hence pi. All right, so here is a little program. All right, and the flow chart works between the statement begin and the statement that says end full stop. All right, or end the period, whichever one you want to call it. All right, let me bring this up a bit so you can see it. Right, so the flow chart really works between here, between the begin and the end, where you're declaring up here both the variables and the constants. Those aren't applicable. The flow chart works between the begin and the end, hence where we have the oval start and the other oval to stop right there. All right, so that's where we're working between. So for each line, you basically use the symbol that's appropriate for the flow chart. For example, here we see x colon equal 1. So this is an input statement. What you're doing is that you are inputting 1 into x. If you didn't have the colon there, what you'll be doing is that you'll be comparing x to 1. You're saying that x has a value, already a predetermined value, or had a value already, and you're comparing it to see if that value is equal to 1. Usually it would have something, for example, like this: if x equal 1, or while, or something like that. But in this particular instance now, what we're saying is that x therefore equals 1. So we're putting 1 into x. So with this line here, sorry, it's an input command, right? So we're putting 1 into x. Hence, the parallelogram here. Remember, each shape represents, so parallelograms are about input-output. All right, rectangles, not necessarily squares, but rectangles are for processes: addition, subtraction, multiplication, division. An oval, as we have here, right here, so that's for start and stop. And the rhombus is when we are making decisions. That is anytime we have less than, greater than, less than equal to, greater than equal to, not equal to, or even equal to. That's what we were saying a while ago. When we have just equal to alone in Pascal, we're saying basically that we're comparing. X has a value, and we're comparing to see if that value is equal to 1. All right, that's basically what we're saying here. All right, if for some other programs you probably have equal, but that's not what we're doing right now. All right, so let's continue. So we start off, have start. So we have begin, we have start. We could put begin if we wish, but choose use start. All right, and we have, so start, oval. The arrow flows downward. So then we go to the next point. We're saying we're putting 1 into x. So here's the parallelogram for that. So the next step, Then we go down. Now we are making a decision. Once of our rhombus, we are comparing. We're looking at the relationship between two things. X compared to 10. Is X less than or equal to 10? We're making a decision. So when we are factoring those kind of processes in, we have a rhombus. And once we're making a decision or relating something, we call it a Boolean operation. We can get only one of two responses. Is X less than or equal to 10? It can be yes or it can be no. And the persons, you can go down for yes or you can go to the left. I was taught that you go to the right or go down. And somehow whatever you learn the first time, it kind of sticks with you and so on. So that's why I always do this, right? Yes, going to the right, or sometimes going downward, and no would go to the left. But people do whichever they want because there are no set rules that you have to do a flowchart a particular way, more than making sure you use the right shapes for the right command. All right, and so forth. So if we go yes, so if X is indeed less than 10, which in the first instance it is, then we go yes. Now, if X is less than 10, then what we do is that we output this command. Give me the radius of any circle, hence give me the radius of a circle. Can I truncate it here so that'll be shorter for the parallelogram? Because the shapes kind of get awkward after a while in using Word. Alright. And this is the output command here, not exactly as I have it here. Alright, not going to fuss about that too much. And then the read command here that says read rad, read the radius. Alright, so we read the radius in and then we do the calculation. Circ therefore equals to radius times 2 times pi, as we had discussed earlier. Alright, so we branched over to yes, and we're doing these are the commands within the loop. These are the commands that we did within the loop. Alright, and the last thing we did was to output. Whoa, I forgot to put the output command, the output here. How careless. Alright, so I should actually have another output command here that would say output circumference is circ. Alright, forgot to put that in. Should have another output command here that would say that. But this is the thing when you're doing in Word, they kind of run out of space. You probably need to download a program such as Direct Draw or something like that where it's a little bit easier. But I'd have to have another output command here after this that would say read radius. Output circumference. So I missed another. Let me copy this. Let me give you an idea what that would be. Control C and Control V. And then I should have another command down here that would say this. Circumference of circle is, let's say circumference is, because I don't have the space, circumference, circ, is circ. Alright, I'll put circumference. So I'm talking about space limitations, and it really is a challenge doing it in Microsoft Word and so on, but right now it is just what we have to do right now. Bear the pain. Circumference is circ, but usually the command resembles more of what you will have in the program. The command will represent will look more like what you have here, but I don't have that. I have a problem with this spacing, so let me remove this. Let me delete this line, delete this, and then I'd have to adjust all of this all the way down under here, and then I'd have to have a connector and so on. All of those things become a problem. Alright, all of those become a problem. And then I have to bring this down and try to keep it straight, because even the shift key sometimes gives problems in trying to keep these things straight. And I'll just copy this down, Control C, Control V, and then put this somewhere here, and then I'd have to draw another line and put that. Alright. I'd have to draw another line from here coming over here. Should be an off-page connector. But let me do the final one. Insert, and then word here, you have the flowchart symbols here. See, flowchart are different symbols here. So I have this line, and let me come across here. Alright. Alright, so that is what happens here. I'm going to come down to the end here and say stop. So that's basically it. Alright, not everything not drawn to scale exactly the way I'd like it, but this is basically what happens. Alright, this is why I'm about to do what I'm going to do now. Go use a CXC IT textbook where they already predefined that stuff for me, so I don't have to bother with the task of drawing these and all of those stuff. So this is generally the idea of how the pie chart, the flow chart would look for our program that we have here. Maybe if I remove this here, and if I remove these, I can have a better time. Remove this, Control X. Alright, maybe I have an easier time getting this done. Alright, bring this down a bit. Alright, so then I can put this down here. Right, and then all I need now, where's my line? Alright, just get another one from here. Just copy this and just place it back, and then I'll just move this over here. So then this looks something like this here. So that's an example of my flow chart. Alright, so you can see it's a little bit tedious and so on, hence why I'm suggesting that maybe I use another application like Direct Draw, 3D Draw, something like that. So this is what the flow chart would look like for one of the programs that we actually did the program for already. And I said flow charts are pretty simple. There is nothing really difficult about flow charts. You know, it's just another way to map the solution through for our program. That's all it really is. That's another way to map the solution through for our program. And there are different ways. You have pseudocode, you have algorithms. Yes, and they are different. If you really spend the time a little bit to check, you realize that pseudocode is really different from algorithms, even though we tend to group them together. Pseudocode, algorithm. Pseudocode, English-like statements. You find them on recipes and so on. Directions when you're building an entertainment center. Directions to find somewhere or to get a task done. Any task. That's pseudocode, using English-like statements. Algorithms tend to have variables and so on, and more programming-looking constructs with write, read, print, input, and the mathematical operators as well. Alright? Now, beyond that though, let us look at our textbook. And I recommend that every CXC student get this textbook. It's extremely good. I mean, clear, crystal clear. Plus, one of the persons who's instrumental in setting the exams, Miss Dr. Glenda Gay, she is the one who wrote the book. So she knows exactly what she's testing for. Alright, went to her workshops about 2 years ago, and they were very informative, and so far what she said is exactly what she's producing for the exam. She is instrumental in the setting of the syllabus, setting of the exam, as well as directing markers how to mark the IT exam. I'm not promoting her book, right? But if something is good, you say it's good. And this is a very good book. Right? I have little one or two issues there that I don't agree with, certain little things, but maybe of a book of 200 odd pages, you must find one or two things, literally one or two. I can't even say reach three, that maybe say, oh, maybe I'll do that differently. But trust me, the book is awesome. If you're a disciplined student, you can read the book and understand its content if you're patient enough. Alright, so she prepared these diagrams. Talk about while and repeat loops, Remember, we said while is like a pre-test loop, while repeat is a post-test loop. So bear that in mind. All right. So these are unbounded, while a for loop is a bounded loop. And so the for loop is preferred when you do know the starting and ending values or the number of times to loop, right? However, flowcharts oftentimes don't work well with for loops. We'll look at that a little bit still. All right. So here are some examples. All right. Look at these two examples and tell me which one you think is a while loop or repeat until or a while. Which one do you think it is? Remember, while loop, pre-test or the test occurs first, then the loop goes through. But while an until loop loops, but the test is done at the end of the loop. So which one? Where do you see the decision being made? All right, it tells you right down here. This is a repeat until loop because the rhombus is down here at the end. While this is the while loop, the test is being done at the top, at the beginning of the loop. All right, and I like these loops. They look nice and official, look much better than mine. All right, you know how they flow and so forth. So let's get into this now. All right. So we're into the symbol. So here's an example of a program with a repeat loop over here and a while loop over here. And the two loops indicate. So basically, what is happening? You start the program, you initialize number to 1, a variable called number. You say while number is less than or equal to 3, yes, you can do this command. Do these. Number equal number plus 1. So what you're doing with this program is that you're adding 1 to number each time. If you look here, you can see it. While number is less than or equal to 3, do begin. Number equal to number plus 1. So the calculation is being done. And if you notice the shapes, the rhombus to make the decision. If it is yes, then you go and do a calculation. Then in the rectangle, then the parallelogram outputs the number and you go back up to the rhombus, right? Because you're going to check again if 3, if you reach 3 yet, because it is 1, then the number is 1, there's a plus 1 again, it becomes 2, but it's still less than or equal to 3, so then you can repeat because it's a while loop, then it becomes 3, and then 3 is equal to 3, so you'll still repeat because 3 is equal to 3, and you said if number is less than or equal to 3, then it comes up, add 1, becomes 4, check again. Number 4 is not less than or equal to 3, so it's no longer true. Then you can say no, and the program stops here. So this is the while loop, and the notation is made here as well. And as you can see now, the repeat until loop comes. So realize where the rhombus is at the end. So the program comes and goes through number equal 1, number equal number plus 1. There are no decisions here now. The program just goes right through. Output the number. Then now at the end of the loop, you check the number. Is number equal to 3? If it is yes, you stop. Remember, a while loop repeats while a condition is false. Remember now. So if the condition is yes, the program stops. But if it is no, the program continues. It repeats while it is false. I go to the loop. Much the same way as a while loop. And that's the end of it. And I mean, it goes through thoroughly. You get a good feel of it. Page 252, I suggest. I think the chapter starts at page 230 or 231. I suggest that you go through the book. Spend the time and go through it. The e-version is the e-version. If you don't have it, you can buy it. I think they're available at Kingston bookshops. Alright. Please get the book. It's extremely important. And remember, the person who's setting the exam is the person who wrote the book. So she knows what she's going to test for and instruct or coach teachers to mark for, and based upon how she influences the syllabus heavily as well. So guys, please, as I said, flowcharts are easy. Spend the time, work through it. Be patient. Remember, if it's easy to learn, it's also easy to forget. Now, what I was saying about for loops is this. A for loop is a bounded loop. So the condition is set. You must loop. You have to go through the steps. Let us say you're going to loop 3 times. For x equal 1 to 3, there are no conditions. There is no less than or equal to in terms of the fact or greater than or equal to, because you have to go through the loop. So it's a bounded loop. It's set to loop. These with the rhombus, it is a possibility to loop. These are what you call unbounded loops. Right? It's based upon a condition. Is it true or false? Hence the rhombus. A for loop must loop. Hence why you don't find much loops having the for construct. They tend to convert it to a while or repeat until, so that the rhombus can be used to show the comparisons. All right? Or the relational conditions, or to make a decision. In a for loop, there's no decision to make. Count from 1 to 3, do that. But this is saying if or while, the if, sorry, is a selection statement. It says while x is less than a particular value, 3 or 10, then do this. Repeat until. Those are conditions, because eventually it might not be less than, it might not be true, or it could be false. So those are conditions. I hope that is kind of clear. I hope I didn't confuse you, but that's the reason you don't have much loops or have much flowcharts with for, because in a for loop you must loop. It's a bounded loop. It is specified. You have to loop, as opposed to while or repeat until. Those are used based upon conditions. All right. Hence the rhombus. All right, guys. Have a good one. Hope that's clear, and I hope this video helps you with your loops. Loops are easy. Sorry, flowcharts are easy. All right. Have a good one, guys. Take care.